Hello, this is the video for lesson 1.4 on advanced constructions. Okay, we'll start with a quick review on what we've already done. Okay, in lessons 1.2 and 1.3, we learned how to perform basic constructions. And now we're going to learn how to construct inscribed regular polygons. In an upcoming activity, we will use these constructions to make really cool designs. Okay, so let's start with some vocabulary for the new lesson. An inscribed polygon is a polygon where each vertex lies on the circle. Alright, so this here is an example because each vertex of this triangle is on the circle. So this triangle is inscribed. Okay, if you take a look at this example, there is the shape here, okay, and it asks how many inscribed polygons are there in the figure. So if you're trying to count them, you have to make sure that you are counting just the shapes that have vertices on the circle. Okay, so this triangle up here, okay, is 1 because each of those touch the circle. This orange triangle, they each touch there. Okay, the quadrilateral, each of these 4 vertices touch the circle. There's this blue triangle, and then there's this purple triangle. So that there would be 5 in that example. Okay, you cannot count this. Okay, that's not inscribed because point O is not on the circle. Okay, you can only count the ones where all 3 touch the circle. Okay, regular polygons. So we're going to go over the different types of polygons, okay, that we can inscribe. A regular polygon is a polygon where all the sides and all the angles, okay, are equal. Okay, so the drawing is over here. Okay, we mark that by giving each of the angles the same amount of arcs and each of the sides the same amount of tick marks. Okay, that is the drawing for that. All right, and these are some of the ones we have. We have an equilateral triangle. Okay, that's where, or a regular triangle, we call it equilateral. Okay, you got all 3 equal sides and all 3 equal angles. Okay, you're going to have 60-degree angles. Okay, square. So I think you know that squares have all right angles and all equal sides. There's regular hexagons have 5, or hexagons have 6 sides. Pentagons are 5. Heptagons have 7 sides, and octagons have 8. Okay. Circumscribed polygon is sort of the opposite of a inscribed. Okay. So an inscribed polygon was when the polygon was inside of a circle, all the vertices touch the circle. Okay, circumscribed, that's where you start with a polygon, okay, and you draw a circle that touches each of the sides exactly once. Okay. All right. Okay, let's go over some examples, figuring out if it's inscribed or circumscribed. Okay, so for this example, so the hexagon is, well, the hexagon is inside of the circle. Okay, all the vertices touch the circle, so this is inscribed. Okay, the circle is circumscribed. The circle is outside. Circumscribed. All right, let's try this. Okay, the pentagon. Okay, the pentagon, each of the sides touches the circle once. Okay, so that's definition for circumscribed. Okay, and the circle is inscribed. Okay, so in review, when a object is inside of a circle, okay, like the hexagon is, it's inscribed. Okay, when a shape is outside, in this case the circle is outside of a pentagon, the circle would be circumscribed. Okay, so now we'll give a shot at the constructions. Okay, we want to first construct an inscribed equilateral triangle. Okay, so the way we're going to do that is we're going to start by drawing a diameter. Okay, so remember, diameters go through the center. Okay, so place your straight edge like that. Okay, here's the center point a little bigger. Okay, draw a diameter. Okay, Alright, so what you're going to do now is you're going to measure from the center to the outside of the circle. Okay, and you can also measure from the edge to the middle. Okay, so get your pointer right on the middle. Okay, and then we're going to, okay, there's two ways to do this. We can make an arc here and here. Okay, or you could simply just make a full circle. Okay, and okay, now what we're going to do is we're pretty much done here. Okay, we're going to connect where this arc was with the other arc. Okay, and then go from this arc up to the diameter. Okay, so if we measure each of these segments, a little over 4 centimeters, a little over 4 centimeters. Okay, all three are going to be, so I just inscribed an equilateral triangle. All right, next we're going to construct an inscribed square. The first step is the same as was for the inscribed equilateral triangle. So we're going to make a diameter, make sure it goes through the center. All right, and so a square has 4 equal sides. Okay, so I want to break the circle up into fourths. Okay, so I would like to make a perpendicular line here. And the way we're going to do that perpendicular line is with our perpendicular line construction. Okay, so we're going to put our pointer on the edge of this diameter. We're going to go a little past where halfway will be. Okay, we'll make an arc above. Actually, let's just make an arc on both sides. We'll go over here. We'll make an arc on both sides. All right, and that is our midpoint. We're pretty much constructing a perpendicular bisector here. Okay, so we got that set up, and we make our line. Okay, should go right through the center, and it does. Okay, now we can just finish off the construction. Okay, by creating segments that touch each of these edges of both diameters. Okay, and now we have an inscribed square. 4 equal sides, 4 equal angles. All right, last up, we're going to construct an inscribed hexagon. All right, and okay, so if I think about this inscribed hexagon, I already made an inscribed equilateral triangle. So triangles have 3 equal sides and angles. Hexagons have 6 equal sides and angles. So if let me draw what's happening here. So for the triangle, we made a diameter. Okay, we measured from here to here. We made an arc from here to there, from there to there. Okay, we had a triangle. All right, but what if we did it the other way around? What if we measured from here to here? We did an arc and an arc. Okay, and we connected this together and then went this way. Well, what we have here is we have 3, 4, 5, 6. We got 6 sides. Okay, so that's the way we're going to do the construction. All right, we're going to pretty much do the equilateral triangle construction. Well, that's one way to do it. Let me show you an easier way to do it. Okay, so the easier way to do it is, okay, we start in the middle. We measure to the outside. Okay, and let's make a dot anywhere on the circle. Okay, so we measured from the center to here. Okay, and then try to get it real precise. Okay, and go from that point. Okay, and arc here. Okay, then go to there and just keep sort of going around. 1, 2, 3, 4, 5, and okay, it almost got back. Okay, I probably wasn't quite precise enough. Okay, with my initial measurement. Okay, I need, you know, if you're real precise with that, it should end up right back where you started. Okay, but yeah, so now you're just going to make that hexagon. So you're going to connect there, connect here, connect here, connect here, there, and here, Okay, and we have our inscribed. Yeah, we try to make it regular. I don't think it's quite regular, but we do want it to be a hexagon, so we're okay here. You could also do this construction with the equilateral triangle and then do it again the opposite way to make the same kind of shape we just did. Alright, so that's the advanced constructions.